So we have started with entering our data as matrices and manipulating matrices and vectors in Python last time. For those of you who haven't made it to the class, have you managed to watch the class online? Or maybe that's due up this weekend, so I hope you can catch up quickly as we go along. So I will just reopen Python. So as a refresher, open up your computers and start with Anaconda. And we are still working in Spider, though today I hope to get to Jupyter Notebooks as well. I will assign a relatively short homework today, by the end of the day. And what we will actually do, we will take our problem from homework 1, the one where you had to compute everything by hand, and you will just redo it in Python. Okay? So should be faster than by hand, I hope. Okay? So let's launch Spider. As a refresher, so I'm typing things into Python as we go along. It seems that my Python here has remembered all of the variables, which is curious. I'm going to clear the screen a little. Okay. So I have all of these variables because I executed this entire script last time. So the script that I posted for you, Lecture2.2, it's posted on Canvas. I'm kind of working through that script, but it's a compilation of all of the commands we're going through. And as a quick refresher, Python as Python has a set of commands that you can work with to just work with. However, for data that comes in matrices, the most effective module, and module is an extension of Python, is called numerical Python or NumPy. There is various options. Okay? I cannot teach you all of the options. I have chosen numerical Python because it's the most common one and most effective one for data that comes in these arrays. Arrays could be 1D, 2D, 3D, 4D, 5D, whatever it is that we want. Most of the time, we don't go beyond 3D. Okay? It's hard to visualize. So we will work with NumPy, and the way I tell Python that I need to work with NumPy is I say import NumPy as NP. And NP is going to be what I'm going to call it for short in my programs, or whatever I type into command line. And the reason we need to know and remember that is that every command from NumPy I want to use, I have to start with np dot, okay? And then the name of the command. So first one was actually creating the array. I'm just going to create any array, x. I'm going to diverge a little from the script. X is np array. And let's say that I want to have 3 elements, 1, 5, and 6. So this is going to be one-dimensional array. I'm giving these numbers all as one array, and I'm encapsulating them in angular brackets. And then I need the regular brackets because I'm passing something to the function. Every time I'm passing something to the function, I need to put it inside of the brackets. Array is the actual name of the function, but it's within NumPy, so I gotta start with np dot array. Boom. So I have x. I wouldn't know it because nothing got printed. I can either print x just to see the values, or I can actually do variable explorer. This variable explorer we have thanks to Spider, which is the environment we're working in. Sometimes you won't have it, depends on which Python environment you're working in which case you always have print command. Okay. So this Explorer, you can go down, and here you can actually see x. And the whole point of why are we doing NumPy and not something else is that I can now work with this x. I can say sine of x. This function sine, oops, I need to do NP sine because it's actually within NumPy. This is sine function. Most of the mathematical functions are there. If you don't recall how to find them, Google. That's the quickest way. There's help within here, but it's kind of intractable to read, so I'm just going to skip showing it. NP.sine of x is going to go, and it's going to compute for every element of my array. That is powerful. Not because of this array. This one I can do by hand. But because in petroleum engineering, I'm going to get an array of numbers as many feet that I have in my reservoir. Could be many feet. If I go horizontally, oh boy. Okay.
I don't know if this is a problem or not, but for the type, mine says int 32.
So this depends on implementation on your computer.
Okay.
And quite frankly, between 2 weeks ago and now, I don't know what I installed on my computer, but by default, it decides to go with integer 64. 64 versus 32 is number of bits it gives to the integer. So in my case, they're bigger, twice bigger. Why? Regular integer shouldn't be 64 bits, but I couldn't tell you. So there are certain decisions here that are made for you. Okay? And based on the numbers I provide, NumPy will just allocate the space for these numbers. And it's looking at 5 and 6, hey, these are integers. Okay? So I'm going to sort them in integers. If I actually did something like this, so Y is my NP array of 3.0, 4.0, and 6.0. Now I'm telling it, hey, this is a floating point, and maybe these are simple ones, but let's do 6.2 just for kicks. Type in any number you want. So now these are so-called floating point numbers, and that's in computer language. They're real numbers. And for real numbers, I need a different type. And apparently I did not close the parentheses. And then it told me, hey, this is not the way you're supposed to write things. I didn't put comma. I made 2 mistakes all in one. Well, this is just to exemplify all of the problems you could possibly have. No, this is because MATLAB can take it without commas. And now I keep typing without commas. Okay. So I need commas in there and all brackets, and now I have Y. And when I print or just say Y, it's going to show me that these are arrays, and it's float 64. Okay? So change the type. And we're going to get to that, but the real numbers and integers are stored in 2 completely different ways. And the point of this is that when you go to the piece of memory that stores this number, you have to know what you store. Otherwise, you're not going to read that piece of memory correctly. And you're just going to get garbage. And I can visualize to you how does it actually look like when you read garbage. Hassan, it's project 1, isn't it? Yeah. So when I go here to the very first project, or maybe second, where's the green, this one, okay? We are not well equipped to read the type of the file that was sent to us, and this is what we see. Instead of nice granular structure of a material, we misread the numbers in memory. And you see noise. So noise, anytime you see noise or some images that make no sense whatsoever, most of the time when it's scrambled like this, that it's completely incoherent, means that you misread the memory. Like it's something like, oh, I interpreted integers as real numbers, or real numbers as integers, or something of that sort. Okay. This is a mistake, and no, you didn't see it on the digital rocks board. But that's And that's, of course, if I'm now working with this data, garbage in, garbage out. You can have a beautiful numerical method, but if it works with the garbage input, it's not going to give anything out. All right. So this is basically the reason why we want to go and use Python, because I can operate with the entire array all at once. Now we moved on and we did matrices, so let's type in A, and I'm just going to type in a different one. I still use NP array. I'm going to provide it inputs in terms of arranged numbers, so therefore I need these brackets, angular ones. And then I have to, if I want a matrix, I do pretty much the same thing, but I separate every row with another set of angular brackets. So if it was a simple 1, 2, comma, 3, 4, I have now typed in 2 different rows, and each row gets another set of brackets. And that way, the function will know, aha, Masha wants matrix. And if I print it, I see a matrix. So it kind of handles them row by row fashion. Python is what's called object-oriented language. And there is something that so there is variables. So far we worked with variables. I defined my array. Okay? Well, this array, or whatever object, doesn't come just with the data. It also comes with certain default things that I want to do with it. Okay? I want to add arrays, I want to print arrays, I want to this or that. So often, I actually have not just object, but also a set of functions that work with that object. And that's called a class. So I'm not going to quiz you on the details of that. I just want you to understand the logic of it. So I can actually interrogate shape of this A by saying, hey, A.shape. It's going to tell me it's 2, 2. So shape is a function that is defined on A. I could actually call it separately, also like np.shape. But I can also, since it's associated with this type of object, I can just say A.shape, okay? And it's information about this shape that I'm asking for, A. Okay. And this is something that is specific for object-oriented programming. So this is 2 by 2. I can also change it, and I can change it in place. And I can just say, make it 4, 1, will you? As long as I have enough numbers, 2 times 2 is 4, 4 times 1 is 4, comes down to the same thing, it's going to reshape it for me. If it doesn't make sense, it won't. Okay? So I can't say 5, 1 here, because I don't have 5 numbers. So now when I print A, I get this. So I asked 4 rows and 1 column. This is 4 rows, and each one has 1 number in there. This is actually a vector now embedded inside of a matrix. It's sort of like a trivial matrix, but it's treated as a matrix, not as a vector. I can now also transpose it. So all of these, again, I'm going a little off, not too much off script. Okay? I can also now create a new matrix, which is NP transpose of A. And that's going to flip rows and columns. So when I print B, I'm going to get a row. and shape of B is 1,4. Yes? So transposing a matrix with any matrix is done well. However, if I defined one-dimensional array, my X was one-dimensional, right? If I try to transpose, and I'm going to say, hey, print it for me, please. It's not going to do anything. It remains the same 1D array that I defined, because one dimension I cannot flip columns and rows in something that is inherently 1D. And I can check that with X shape. It's 3, nothing. So this is a 1D array. It does not have the second dimension. It's a nuance. Okay? It's a detail, but this detail in implementation can, if you're forcing transpose and it doesn't do anything and you're frustrating, why not? This is why not. So if I'm treating something as 1D array, I can't transpose, or I do nothing. The transpose just does nothing. I have to have a two-dimensional object to actually flip rows and columns. That's all. And the reason computer is very picky about it is that computer doesn't conceptualize, you do. Okay? So there's a certain way that it's implemented, and that is strictly enforced, because otherwise computer is fully confused. So recall in this class, whatever it is that you type in, computer does only precisely what you tell it to. It might seem complex, but not on these computers. There's no artificial intelligence behind it, okay? It's only the intelligence you provide. Or maybe I should call it the attention to detail you provide. Okay, so those are shapes. And then, again, shape, you can also just do NP shape. But now I'm just calling a general NP function, and I have to give it this object it's working on. So you can do the same thing by just saying NP shape. So there's always choice in Python. It's kind of very democratic. That can be a little confusing. But again, I can do a.shape, in which case A is the object I'm giving the function to. And it actually travels with that A. And there's np.shape. Those are actually two different functions shaped in two different roles. Okay. Let's now get to multiplication. I am going to give myself another two functions, and I'm going to be so imaginative that I'm going to give myself a 3 by 2 matrix NP array 1, 2, and since I'm very imaginative on Friday afternoon at the end of a long week, the best I can come up with is 1, 2, 3, 4, 5, 6. Whoops, and again I edited something again. I did not close the second set of brackets. Okay. So again, if you're interested in how it looks like printed, and I'm gonna give myself another matrix F just to practice typing this a little. And you can give it this 1, 2, 0, 1 or something else, whatever you'd like. I'm gonna go off script a little. I'm gonna go with 0, 4, and 3, 8, just because. Whoops, and I did it again. This is me trying to get off the previous syntax I used. Okay. So shape of E is 3 by 2. Shape of F is 2 by 2. Can I multiply E times F in terms of matrices? And there is a function called np.matmul. So it's matrix multiplication. I'm going to say EF. I hope it's correct. This is where we would need to do a little check by hand. Can I do F times E? 2 by 2 times a 3 by 2? No. Well, let's give it a shot anyway. We're going to get value error. Shapes 2, 2 and 3, 2 are not aligned. So when you see this, that means that you try to multiply matrices whose dimensions do not match or are not aligned in Python language. It's looking for this dimension 1. Remember, that's actually the second dimension. There is dimension 0 and dimension 1. I start from 0 in Python. So this dimension 1 is 2, is different from dimension 0 in the second matrix, which is 3. So 2 is not equal to 3. So it's trying to tell you what's wrong, though most likely when you read this, you'll be like, say what? Okay? So you gotta get used to the error messages that come your way. So if I wanted to do vector, okay, I had a 3 by 2 matrix and a 2 by 2 matrix. What is the size of the vector that I need to have? 2 by vector, 2 by 1, right? To actually multiply a matrix that is 2 by 2 or 3 by 2 and that vector. Well, none of my x's and y's is in that shape. I'm going to actually, and I'm going to attempt something. I'm going to call this vector f, also to make a point that uppercase f and lowercase f are not the same thing. And I'm going to define an NP array as 4, 5. The dimension of this is just 2. It's a 1D array, okay? And I am actually allowed to multiply my 2 by 2, which is a 2D array. Let's go with F. And my 1D vector. Let's see if I'm allowed, actually. I am. Okay? And the result is a vector, meaning that when dealing with one first thing, the function is intelligent enough. That is, some programmer was intelligent enough to program it in a way to accept vector regardless of not being a matrix. So it's not a row vector or column vector, it's just a vector in 1D world of Python. And then it's going to just check, oh, is the number of columns in my matrix the same as the number of elements in this array, and it's going to do the multiplication. And the result is presented to us as, again, 1D array. This looks like a row vector, but it's not a row vector, it's just a 1D array. And the way I check is that when I check the shape, it's 2, nothing, it's 1D array. So in Python world, row vector or column vector, if it's a one-dimensional vector, it doesn't matter. It's all the same. Okay. So this is my result. If I wanted to refer to that result later, right now it's kind of gone. Okay? I computed it and I didn't catch the value. So if I need that value for something else and I want to store it in memory, I have to define a variable with its name. And I can do that by giving that variable a very inventive name, such as h. I'm going down the alphabet, going down the numbers. Again, very imaginative. And then indeed, this 20 and 52 show up as a variable, and now I can actually go and say, hey, what is my first element of this array? It's h of 0. Again, we are starting with 0. Numbering starts from 0. And the second element is h of 1. Quick quiz for those of you who were in class or watched the video last time. How do I get the last element in an array? -1. So let's try with this f. F of -1 is 5. Is it? 4, 5? Yes. I can even go next to last.
Can you keep going?
Well, let's try. Typically, you have a memory error because now you're reaching into the memory that is not defined for this variable. Index error. You don't have this many indices, Marsha. So -3 is out of bounds. I have, if I start with 0 and I have size 2. Sometimes, mysteriously, some programs will allow you to do it. And then you have an error and you don't know. But what it literally is, you have a part in memory that's stored, this number of yours, and you literally reached into this part of memory and grabbed the value, which is garbage. It exists, but it's garbage, right? So it's actually good when it has an error immediately. Then you don't have hidden stuff. Right. All right. So now we're going to move on for another 2 minutes of this class. And we're going to learn. Oh, I did this already. Oh, we want to go to. We're just going to do this in the regular Python. We're not going to introduce Jupyter Notebooks at the end of the class. So now we actually want to be a little more better than this. I can type in my 1, 2, 3, 4, 5, 6 all day long. That's very boring and very limited, and I'm not good at typing. Okay? So I sometimes want to just create myself an array that has a large number. Right? And there are some functions. 3 first ones that we're going to use are linspace, arrange, and log space. So try typing in this. Okay? X equals to np.linspace. That means that this is again a NumPy function. So np dot is for NumPy. And linspace, the way I normally use this is I give it a start, I give it an end, and how many values in between. So give it a start 1, give it a end 100, and go for 10 values. It's going to linearly space 10 values in between 1 and 100. And there's no need for me to tell you, but I'm going to say it anyway. You can come up with any start, any end, and number of values, but that end should be larger than the start. Okay. If you do arrange, it's a similar deal, so try it out. But you're going to specify what is going to be the spacing in between these. So it's going to do equal spacing. And in this case, you're going to get the same result if you do 10 values in between 1 and 100. They're going to be every 11. Okay? So spacing is actually 11. When the spacing doesn't match, you might give it a spacing that doesn't go well in there. It's going to come up with the next, closest possible result for this. And log space again does the same thing. It just uses logarithm space. So it's going to be, if I give it 3 values between 1 and 3, it's interpreting this as 10 to the 1 and 10 to the 3. So it's going to be between 1 and 1,000. So it's just on a logarithm axis, if you will. Okay. So it's going to give the result 1, 10, 100, so forth. All right, I will see you on Monday. I will assign this relatively short homework to redo our hand calculations in Python by the end of today.